In this section, we have discussed various ways in which we might lose our influence over the goals and actions of AIs. Whereas the risks associated with competitive pressures, malicious use, and organizational safety can be addressed with both social and technical interventions, AI control is an inherent problem with this technology and requires a greater proportion of technical effort. We will now discuss suggestions for mitigating this risk and highlight some important research areas for maintaining control. Avoid the riskiest use cases. Certain use cases of AI carry far more risks than others. Until safety has been conclusively demonstrated, companies should not be able to deploy AIs in high-risk settings. For example, AI systems should not accept requests to autonomously pursue open-ended goals requiring significant real-world interaction, e.g., make as much money as possible, at least until control research conclusively demonstrates the safety of those systems. AI systems should be trained never to make threats to reduce the possibility of them manipulating individuals. Lastly, AI systems should not be deployed in settings that would make shutting them down extremely costly or infeasible, such as in critical infrastructure. Symmetric international off-switch. Countries around the world, including key players such as the US, UK, and China, should collaborate to establish a symmetric international off-switch for AI systems. This shared off-switch would provide a means to rapidly deactivate AI systems globally if deemed necessary, such as if rogue AIs are emerging or if there is an urgent risk of extinction. If rogue AIs emerge, having the capacity to pull the plug instantly is crucial, rather than scrambling to devise containment strategies amid escalating problems. A successful off-switch would require increased transparency and monitoring in AI development and operations, such as Know Your Customer systems. So creating an off-switch also creates important infrastructure for mitigating other risks. Legal liability for cloud compute providers. Cloud compute providers should take steps to ensure that their platforms are not helping rogue AIs survive and spread. If we impose legal liabilities, cloud compute providers would be motivated to ensure that agents running on their hardware are safe. If providers find an unsafe agent on their server, they could hit the off switch for the portions of their systems used by rogue agents. We note that this intervention is limited in its effectiveness whenever the rogue AIs can easily manipulate or bypass the AI compute monitors. To strengthen this liability framework, we could imitate international agreements for cyber attacks, essentially creating a decentralized off switch. This would allow for swift interventions if rogue AIs start spreading. Support AI safety research. Many paths toward improved AI control require technical research. The following technical machine learning research areas aim to address problems of AI control. Each research area could be substantially advanced with an increase in focus and funding from industry, private foundations, and government. Adversarial robustness of proxy models. AI systems are typically trained with reward or loss signals that imperfectly specify desired behavior. For example, AIs may exploit weaknesses in the oversight schemes used to train them. Increasingly, the systems providing oversight are AIs themselves. To reduce the chance that AI models will exploit defects in AIs providing oversight, research is needed in increasing the adversarial robustness of AI models providing oversight, proxy models. Because oversight schemes and metrics may eventually be gamed, it is also important to be able to detect when this might be happening so the risk can be mitigated. Model honesty. AI systems may fail to accurately report their internal state. In the future, systems may deceive their operators in order to appear beneficial when they are actually very dangerous. Model honesty research aims to make model outputs conform to a model's internal beliefs as closely as possible. Research can identify techniques to understand a model's internal state or make its outputs more honest and more faithful to its internal state. Transparency and representation engineering. Deep learning models are notoriously difficult to understand. Better visibility into their inner workings would allow humans, and potentially other AI systems, to identify problems more quickly. Research can include analysis of small components, or it can try to understand a network's high-level internal representations. Detecting and removing hidden model functionality. Deep learning models may now or in the future contain dangerous functionality, such as the capacity for deception, Trojans, or biological engineering capabilities that should be removed from those models. Research could focus on identifying and removing these functionalities. Positive vision. In an ideal scenario, we would have full confidence in the controllability of AI systems both now and in the future. Reliable mechanisms would be in place to ensure that AI systems do not act deceptively. There would be a strong understanding of AI system internals, sufficient to have knowledge of a system's tendencies and goals. These tools would allow us to avoid building systems that are deserving of moral consideration or rights. AI systems would be directed to promote a pluralistic set of diverse values, ensuring the enhancement of certain values doesn't lead to the total neglect of others. AI assistants could act as advisors, giving us ideal advice and helping us make better decisions according to our own values. In general, AIs would improve social welfare and allow for corrections in cases of error or as human values naturally evolve.